Hello guys, my name is Bino, and in this video we'll be focusing on question 6 from the April 2nd 2020 N5 mathematics question paper. Question 6.1 states that you must determine the particular solution of dy over dx is equals to x multiplied by e to the power x squared plus 2 all divided by 6y squared when x is equals to 0 and y is equals to 1. That's what that means. So in this case we have to group all the functions with y one side and group all the functions with x one side, and we integrate these functions of y with respect to y and integrate these functions of x with respect to x. So we have dy over dx is equals to x multiplied by e to the power x squared plus 2 divided by 6y squared. So in this case we have to multiply both sides by dx, so that dx will cancel out with that dx, and dy will be equals to x into e to the power x squared plus 2 dx all divided by 6y squared. And from here we have to multiply both sides of this equation by the 6y squared so that we can have this function y grouped with that dy. So we multiply both sides by 6y squared, and or you can multiply by y squared and leave the 6. The choice is up to you. So this 6y squared will cancel out with that 6y squared, and on the left hand side we will have 6y squared dy, and on the right hand side we will have x into e to the power x squared plus 2 dx. From here we integrate the left hand side with respect to y, and we integrate the left hand side with respect to y, and we integrate the right hand side with respect to the x. So the integral of this y squared with respect to y will be equals to y to the power 3 over 3, and to integrate this right hand side we have to let u equal that x squared, because when we differentiate that u we will get a function. So the derivative of this with respect to x is equals to 2x, and this x and that x have the same power. So we can rearrange our integral. So this 6 divided by that 3 will be equals to 2y cubed e to the power x squared plus 2. Let's write this x here, dx. So in this side let's multiply both sides of this equation by the dx, so that dx will cancel that dx, and du will be equals to 2x dx. We have x dx here, it doesn't have this 2, so let's divide both sides by 2. That 2 will cancel out with that 2, and du over 2 will be equals to x dx. So in the place of this x dx we will substitute du over 2, and in the place of that x squared we will substitute u. In the place of the x dx we substitute du over 2, because du over 2 is equals to x dx. So now we have to integrate this e to the power u with respect to u. So the integral of e to the power u is e to the power u. We integrate this 2 with respect to u. So the integral of 2 is 2u. We still have this 1 over 2 here, which we must not forget. So and plus c, because we integrated. So to determine, so they said that we must determine the particular solution and not the general solution, and we are given that y0 is equals to 1. In other words, when x is equals to 0, y is equals to 1. So in the place of that, so to determine this value, this constant c, in the place of y we will substitute 1, and that 1 cube will be equals to 1, and in the place of, so now we have to bring back the x squared because we have to substitute x for 0. So let's bring back the x squared in the place of the u. So e to the power 0 will be equals to 1 plus 2 multiplied by 0 squared will be equals to 0, 1 over 2 plus c. 1 multiplied by that 1 over 2 will be equals to 1 over 2 plus c. So c will be equals to 2 minus 1 over 2, which is equals to, so when we take this 1 over 2 to the left, is going to change sign from positive to negative. So 2 minus 1 over 2 will be equals to 3 over 2, 1,5. So we'll have 2y cubed is equals to, so in the place of that, we're supposed to substitute back the x squared. So ex squared plus 2x squared multiplied by 1 over 2, and c we determine as 3 over 2. So this is our particular solution for question 6.1. The particular solution of x squared d squared y divided by d x squared is equal to x to the power 6 plus x to the power 3 minus 2x squared if dy over dx is equal to 3 over 5, x is equal to 1, and y is equal to 1 over 5. So we have to make sure that there is no any function before the dy squared over dx squared. So we multiply both sides of the equation by that x squared so that we can have dy squared dx squared without any function before it. So what you do on the left, you also do on the right. So that x squared will cancel out with that. The x squared and dy squared over dx squared will be equals to x to the power 6 divided by x to the power 2 will be equals to x to the power 4. X to the power 3 divided by x squared will be equals to x negative. So that x squared will cancel out with that x squared and you'll be left with 2. So from here, so if we had dy squared over dx squared, when you integrate this, you'll be left with dy over dx. You integrate this, you'll be left with you'll be left with y. So we have to integrate this dx, this dy squared over dx squared, and when we integrate it, we'll be left with dy over dx. But in order for us to make sure that this equation remains balanced, we also have to integrate the right hand side. So what we do on the left, you also do on the right. So the integral of x to the power 4 will be x to the power 5 over 5 plus the integral of x is x squared over 2. The integral of negative 2 will be equal to negative 2x plus our constant, let's name it constant 1. So we integrate that. So before we integrate, we have to figure out what this c1 will be equals to. So we are given those boundaries so that we can be able to figure out the value of this constant c1. You can call it constant a or b. So when dy over dx is equals to 3 over 5, x is equals to 1, so we have 1 over 5 plus, where there is x, we substitute 1 plus c1. From here, we'll have 3 over 5 minus, so we take this to the left, and that as well to the left, and the 2 to the left, and c1 will be equals to 3 over 5 minus 1 over 5 minus 1 over 2 plus 2, so c1 will be equals to 19 over 10. So we can rewrite that with the value of c1. So we have dy over dx is equals to x to the power 5 over 5 plus x squared over 2 minus 2x plus our c1, which we determine as 19 over 10. So we integrate this left hand side again. So when we integrate this dy over dx, we'll have y, and we cannot just integrate the left without integrating the right. So the integral of x to the power 5 is x to the power 6. We have that x, that 5, and the new 6 plus the integral of x squared is x to the power 3 over 3, and our original 2. The integral of x will be equals to x squared over 2 plus the integral of 19 over 10 is 19 over 10x plus our second constant 2 because we are integrating. So now we have to determine the value. Before we do that, let's 5 multiplied by 6 plus x cubed over 2 multiplied by 3, which is 6. That 2 will cancel out with that 2, and we'll have negative x squared plus 19 over 10x plus c2. So we determine the value of c2. So we substitute. So where there is y, we substitute that 1 over 5. And again, where there is x, we substitute 1. So this will be 1 over 30 plus 1 over 6 minus 1 plus 19 over 10 plus c2. So 1 over 30 plus 1 over 6 minus 1 plus 19 over 10 will be equals to, so we'll have 1 over 5 is equals to 11 over 10 plus c2. So to determine the value of c2, we take this 11 to the right, to the left, and we flip the equation. So it's going to change sign to negative 11 over 10. So 1 over 5. So c2 will be equals to 1 over 5 minus 11 over 10, which is negative 9 over 10. So we write that equation now with the value of c2 as negative. So y will be equals to y will be equals to x to the power 6 over 30 plus x cubed over 6 minus x squared plus 19 over 10x plus our c2, which we determine as negative 9 over 10. So this will be our particular solution for question 6.2.